Good morning. I'm Devasena. In this lecture, we are going to discuss about stepper motors and its various types. This topic is present in the subject mechatronics. Actuators. In a control system, the element which transforms the output of a controller into a controlling action or motion is called as actuators. Actuators produce physical changes such as linear and angular displacements. Examples of actuators are solenoids, electric motors, hydraulic cylinders, pneumatic cylinders, and motors. Actuators can handle the static or dynamic loads placed on it by control valve. The important aspects of actuators are proper selection and sizing. Functions of actuator. An actuator has two major functions. The first one is to respond an external signal directed to it, causing inner valve to move accordingly. Hence, to control flow rate of fluid by positioning the control valve. Second, to provide support for valve accessories. Example, limit switches, solenoid valves. Classification of actuators. Actuators are available in various forms to suit the particular requirement of process control. It can be classified into three major categories. They are pneumatic actuators, hydraulic actuators, and electrical actuators. Let us start discussing about the stepper motor and its types. A stepper motor is an electromechanical device which converts electrical pulses into discrete mechanical movements. These motors rotate a specific number of degrees as a respond to each input electric pulse. Typical types of stepper motors can rotate 2 degree, 2.5 degree, 5 degree, 7.5 degree and 15 degree per input electrical pulse. Rotor position sensor or sensorless feedback based techniques can be used to adjust the output response in accordance with the reference command input. The speed of the motor shaft's rotation is directly related to the frequency of the input pulses, and the length of rotation is directly related to the number of input pulses applied. Stepper motors offers many attractive features such as available resolution ranging from several steps up to 400 steps or higher per resolution, several horsepower ratings, ability to track signals as fast as 1200 pulses per second. Stepper motor types. There are three basic stepper motor types. They are variable reluctance type stepper motor, permanent magnet type stepper motor, and hybrid stepper motor. Variable reluctance type stepper motor. This type of stepper motor has been around for a long time. It is probably the easiest to understand from a structural point of view. Variable reluctance stepping motors have 3 to 5 windings and a common terminal connection, creating several phases on the stator. The rotor is toothed and made of metal, but is not permanently magnetized. A simplified variable reluctance stepping motor is shown here. In this figure, the rotor has 4 teeth and the stator has 3 independent windings, that is 6 phases, creating 30-degree steps. The rotation of a variable reluctance stepping motor is produced by energizing individual windings. When a winding is energized, current flows and magnetic poles are created, which attracts the metal teeth of the rotor. The rotor moves one step to align the offset teeth to the energized winding. At this position, the next adjacent windings can be energized to continue rotation to another step, or the current winding can remain energized to hold the motor at its current position. When the phases are turned on sequentially, the rotor rotates continuously. The full rotation requires 12 steps for a variable reluctance motor. Typical variable reluctance motors have more teeth and use a tooth pole along with a toothed rotor to produce step angles near 1 degree. Let us discuss the permanent magnet stepper motor type. Permanent magnet stepper motors are similar in construction to that of variable reluctance stepper motors, except that the rotor is made of permanent magnet. A permanent magnet stepping motor consists of a stator with windings and a rotor with permanent magnet poles. Stepping motors with magnetized rotors provide greater flux and torque than motors with variable reluctance. The motor is shown here has 3 rotor propels and 2 independent stator winding creates 30-degree steps. Motors with the permanent magnets are subjected to influence from the back EMF of the rotor, which limits the maximum speed. Therefore, when high speeds are required, motors with variable reluctance are preferred over motors with permanent magnet. Let us discuss about hybrid stepper motor. The hybrid stepper motors have the combination of the best properties of variable reluctance and permanent magnet steppers. So they are more expensive than the permanent magnet stepper motor. These motors provide better performance with respect to step revolution, torque and speed. The rotor of a hybrid stepper is multi-toothed like the variable reluctance steppers, and it contains an axially magnetized concentric magnet around its shaft. The teeth on the rotor provide an even better path which helps guide the magnetic flux to preferred locations in the air gap. The most commonly used types of stepper motors are the hybrid and permanent magnet. The designers prefer permanent magnets unless their project requires the hybrid steppers, since the cost of permanent magnets are less than of hybrids. Thank you very much for listening this lecture. If you like this lecture means kindly share this video to your friends. For further updates, kindly subscribe my channel. Thank you.